In this video we have problem number 4 in this particular series of integration problems. You want to give this a try, go ahead and pause the video and I'll be right back. That type of situation usually leads to integration by parts, even if this was a cosine. And it doesn't really matter what you pick for u or for dv, it'll still come out. And I am going to use the abbreviated form of integration by parts. Some people call it the DI method, tabular method. Again, it's just abbreviated form. So I'm going to put u to the 2x here under the d for derivative, and on the right side under I for integral or integration, I'm going to put the sine of 3x. And what we do is take the derivative of the expression under the d and the integral for the one under the I. If you had like an x squared, you'd go x squared, derivative is 2x, the next derivative is 2, and then it goes to 0. That's what you want, because then you're pretty much finished if that happens. But in this case, you can take the derivative of e to the 2x forever, never goes to 0. Same thing if I put the sign on that side. So taking the derivative of e to the 2x would give me e to the 2x. And then chain rule, the derivative of 2x is 2, that goes out in front. And I do it again. Derivative of 2 e to 2x is, start off with e to 2x again. And then the derivative of 2x again is 2, but now we have a factor of 2 there. 2 times 2 is 4, so we got this. And then I'll stop there for now. It's possible you'd have to go further. But here's what we're going to do. We know it's not going to go to 0 there. So we integrate the other side. Antiderivative of sine is negative cosine. I'll put cosine 3x. And of course the derivative of 3x is 3, so I have to have this 1/3 here. And then the antiderivative of cosine is sine. So put the sine here. Again, the argument is 3x. And I guess because I have the negative there, I have to bring that along. And then another factor, in this case 1/3, so this will be minus 1/9. Now here's the way it works. Anytime you multiply along a row, that's an integral. So notice, if I multiply e to the 2x, sine of 3x, I get the original integrand. But what we do, which is a shortcut again of integration, we cross multiply on the left side. We start off with a plus, a minus, and a plus. The signs alternate all the way until you finish. In this case, you stop this derivative on the left side when the original integral repeats. So notice I started off with an e and a sine. And now when I get to this derivative here, this one, I have an e to the 2x and a sine. Whenever that repeats, you stop there. And this is the way we're going to do it. This will equal to, we multiply diagonally this way. So it'll be e to the 2x times this minus 1/3. So e to the 2x, and I put the minus 1/3 out in front. And then the cosine, 3x. You bring the sign along here. Take the sign. Now the next one, I have a minus 2 e to 2x, and then diagonally multiply this way. And now notice I have a negative there, and then a minus 1/9 there. So that's going to become a positive. So it'll be positive 2/9. And have again the e to the 2x and the sine of 3x. Since when the row repeats the original integral, you stop there, but you still multiply, take the sign with it, so this is going to be a minus here. This will be a minus the integral. This minus because of this minus 1/9 here. And this is going to be, and I'm going to take the 4 out here. Or actually the 4/9. I'm going to take that out, put it out here. Because it's going to be 4 times the negative 1/9. So factor that out. And then I get e to the 2x sine to the 3x. Now sometimes it's going to happen that when you get to this last step here, this with this integral here or integrand here, you're able to integrate it. So you put in whatever you got, and if your constant of integration, you're finished. But in this case, we wind up where we started. We have e to the 2x sine of 3x. So what we do is we bring this integral to the left side. So we add this to both sides, so it's going to cancel it here, it's going to cancel it here, and take it to the other side. So on the other side then, it's going to be one of these and negative 4/9 of these, so we're adding it, so it's 4/9. So 4/9 and 1 is 13/9 of this integral here. So that's e to the 2x sine of 3x dx. Now this part's okay. That's part of the answer. So I'm just going to bring that over, bring it down here, and I'm going to say that's going to be a minus 1/3 e to the 2x cosine of 3x, and then a plus 2/9 e to the 2x sine of 3x. Then I'm going to put this in parentheses here. Now really this is, I want to solve for this. So that's just, if you had say 13/9x equal to some number on the right side, and you wanted to solve for x, you would multiply both sides by the reciprocal of this. This would cancel out. Now you've isolated that integral, just like isolating x, and you multiply this other side by 9/13. Just to make it a little bit shorter here, that's just, okay, this cancels to 1. So now we just have the integral. So basically this, I can multiply here by 9/13, multiply 9/13 times minus 1/3, reduce it, and multiply the next term here by 9/13. The 9 will cancel, but I'm going to leave it like that. You can simplify if you want, and this is your constant of integration, and that's your solution. So just a little reminder, when you're doing this abbreviated form of the integration by parts, the easiest problems are the ones where you have, say, like an x to the third or x to the fifth, because there you just take the derivative until you get 0, and then you stop when you get 0, and then you just go the cross multiplication. Make sure you alternate the signs here, plus, minus, and you don't have to integrate anything if it goes to 0. Now when you have one like this where you know it's going to repeat, you stop when the product of a row gives you back the original integral, and it works out something like this. And there's another case where you can see you can't say integrate the right side further, so you can stop at a point. As long as the product of a row is something you can integrate, you can work the problem this way. So in this case, this is your answer. Thanks for watching. We'll see you next time.